All right, what'd you guys get for number 1? Everybody get 6? Yep. All right, so this is called a quick review, guys. We'll review topics as we go over problems, okay? Can I trust you guys right now that if your laptop's open, you're on the geometry stuff? Yes, kid? Leon? Yeah. Right. This is called a congruent statement. E, F, G, J, K, L. They tell you the order for a reason. If you're trying to find KL, KL is the same as FG. FG is 6. KL is 6. So don't try to eyeball it. Don't try to say, oh, well, it looks like that one goes with that one. Use the congruent statement if they give you one. Make sense? Awesome. Let's see. Next one we did was 4 and then 6. 4. Regis leans a 10-foot ladder against a wall. The base of the ladder makes a 65-degree angle with the ground. What is the distance in feet from the base of the ladder to the base of the wall? All right. Is it Jackson again? Oh, hello. This is Warlash.
I didn't know. I don't know. Or like kind of make them when you make them smaller and like how to figure out what and my computer was that, so it was like so hard to do these sounds.
All right, let's start our answer first. All right. Did you get something between 4.2 and 4.23? 4.2 or 4.2 to 4.23 is what they accepted. How do you do on that? Part is fine? Be honest. Sokotella? All right. So this is 65 degrees. What'd you use? Sine, cosine, or tangent for part A? Cosine, because we're trying to find how far is the ladder from the base of the wall. You're trying to find x there. So adjacent is x, hypotenuse is 10. All you have to do is take the cosine of 65 and multiply by 10. Good. All right, next. Regis needs to move the ladder so that it reaches a window 9.6 feet above the ground. The ladder is still 10 feet long. How many feet closer to the building does he need to move the base of the ladder? So did you recognize it's not asking how far is the base of the ladder away from the wall? It's asking for how far closer to the building did it have to move. Do you agree? So if you got part A, how far was it from the building? 4.2. Now we're going to find how close it is to the building and then do what with those two values? Subtract. Very good. All right. What would be appropriate? By the way, you couldn't use 65 anymore, could you? Do you need an angle? No, you can use the Pythagorean theorem. Be careful that 10 is your hypotenuse. So that's kind of a clever way for them to do Sokotella and Pythagorean theorem in the same problem. Tell.
Did you show how to solve?
Sure. X squared plus 9.6 squared equals 10 squared. Hey guys, quiet please. Hey, as we go through this, hey guys, listen up. As we go through this, I'm going to try to show you some ways. We've already learned all this stuff. I'm going to try to show you some ways that make things easier on the computer or in the calculator. All right. So on the calculator, we've done how many Pythagorean theorems this year? So many. Let me show you a shortcut. Okay. Do you agree I'm going to take 10 squared minus 9.6 squared and take the square root? Here's what I do once you get comfortable with it. 10 squared minus 9.6 squared. I hit enter, and then I square root the answer. 2.8. That's exact. I never rounded. That's exact. All right. So 2.8 is how far it is away from the wall right now. 2.8. So then I take 4.2 minus the answer of 2.8, and I get 1.4 feet closer to the wall. It moved 1.4 feet closer to the wall. Does that make sense? That's how far it was in part A. How many of you got that? Just 2 people? Do you understand how to do it now? That's the thing. Even if you didn't get it right, I bet you would look at it now and be like, oh yeah, I think I could do that now. All right, was that number 4?
Yeah.
Was the next one you did number 6?
Yeah.
Well, that was 5, wasn't it?
We went for 4 or 6.
Wait, why did they? Did we do 5?
No, that was 4.
Oh, why did they call it number? That's weird. All right. Hopefully this was easy for you. Did you remember the formula? Do you have your formula sheet out? Is it on there? Only reason I'm saying this, even if it's not on there, I kind of forget, to be honest. I want you to get into the habit of just, hey, is it on there? Do I need it? Get used to having it out. So get used to using it.
Was it the one that was like C?
That's the circumference of the circle.
Oh, I thought it was the answer.
Does it give you the general form for the equation of a circle? Okay. I guess it doesn't give it to you. Do you guys remember what it is?
Yeah, I remember.
All right, in general. Now, we need to kind of piece something together here. We asked about 2 pi r. That's to find the circumference of a circle. Pi r squared is to find the area inside of a circle. If you're actually going to graph a circle on the xy coordinate plane, there's a formula with x's and y's in it, right? What is it? X minus h quantity squared plus equals r squared. Good. H and k were the coordinates of the center. This is the center. And the radius is r, not r squared. The radius is r. So to create the equation of the circle that has a center of 1, 3, wouldn't I do x minus 1 squared plus y minus 3 squared equals 16, which is 4 squared? That's the correct answer.
Do you really that?
Yeah, that's the equation. Leave it just like that. Do you remember where that came from? Here's the way, if you ever forget, it might be helpful to remember, hey, where did that come from? That way I remember whether it's subtraction or addition inside. Anybody remember where that came from?
Isn't it the distance one?
Good job, Ella. Yeah. Yeah, on a graph, if I have from here to here, isn't that called the radius if I drew a circle like that, right? And isn't this the point HK, which is the center, and isn't this the radius? And this is some point XY. Okay? Do you agree? HK is the center and any XY is on the circle.
Yeah.
So how would I find the distance from HK to XY? Well, Ella said distance formula. So x minus h, x2 minus x1 squared plus y2 minus y1, so y minus k squared. And that was the square root, and that equaled the distance, which is called r. Now, this to this, we just had to square both sides. Do you agree? It came from the distance formula. So if you ever forget, is it subtraction? Is it addition? I forget. Remember, it's the distance formula. It's a fancy distance formula, all right? Next. Did you guys do this one?
Yes.
Let me see if I have it on mine. All right. Don't get overwhelmed as you're reading these. Don't get lost in the words. Okay. Remind yourself of the parts. So what does the translated mean?
To move.
To slide, right? To shift. So circle P is similar to circle Q. Well, we knew that. All circles are similar, aren't they? Right? They all have the same shape, just different sizes. All right. Circle P is translated T units to the right. The image is then dilated about its center by a scale factor of S. How many get lost in the words? Nobody? Oh, wow. You guys are good readers. I would have if I was in high school. All right. So, first thing I'm thinking of, translated to the right. Okay, well, if T is the value of translated to the right, I need to know what was the original pre-image and what's the new one, image. Well, isn't P the one that's being moved, right? So if you told this circle to end up there, it's translated, how many units is T? Yeah, from -5 to 8 is 13 units. So T is 13. Good. T is 13. And then dilated by a scale factor of S. Do you expect S to be a number more than 1 or less than 1?
More because it's getting bigger.
Agreed. We go from a radius of 4 to a radius of 7. What did you guys get for S? Okay, they have a fraction button. I don't know if it's just me, but I don't trust online tests all the time to like count my decimal answer correct. So I'd probably enter this as a fraction. What's the fraction?
7/4.
Good, 7/4. Yep. We'll take it. Whoa. There. 7/4. It's a weird day. All right. Remember, it's new divided by original. Remember, the dilation was new divided by original. 7 divided by 4. Okay? Questions on that one? And have you guys used that fraction, that button online before?
Yeah.
Enter it. You can enter the numerator denominator. Cool. Okay, their numbers are all messed up. Did you guys do this one?
Yeah.
Is this your last problem? Was there one more?
That
Okay.
was our number 9.
Okay, yeah, their number is all messed up. This was your number 9.
Mm-hmm.
Thank you. All right. A triangle JLM and line segment KN are given. A proof of, listen please. A proof of JK over JL equals JN over JM is shown. So as soon as you read that, you should be like, you could draw this on your graph paper if you wanted to just sketch it and mark it up. JK over JL equals JN over JM. Okay? Now, as soon as you read that, what does it look like? What topic does it look like they're trying to show you?
The triangle.
When did we do ratios of sides? Like this side over this side equals this side over this side. Remember what that's called? Are these two triangles congruent?
Yeah, because
This little triangle inside this big triangle.
when they give you
We don't know, but
When you give two sides, it's congruent then.
does this triangle? I mean, I'm not going off of looks all the time, but I mean, they're really messing with you they're trying to say prove these are congruent, right? That's just mean. See this little triangle? See this big triangle? They're not congruent, right? I mean, they're not the same. They're similar. We're trying to see if they're similar. If they're similar, their sides would be not congruent, same length. proportional, right? Proportional. Remember this? How do we show triangles are proportional? Not SSS, SAS, ASA, AAS, or HL. Those were congruents. But there were similarity ones that were similar to those. SSS, similarity, good. This SSS does not mean all three sides are congruent. They were proportional. You guys remember the other ones? AA, good. HL wasn't one. SAS, similarity. Yeah. Two sides were similar and the angle, the included angle was congruent. Remember, angles are congruent in similar triangles. Angles are congruent, sides are proportional. This is our review, okay? Angles are congruent, sides are proportional. So SAS would mean this side is proportional to this side. This angle in the little triangle is congruent to the angle in the big triangle, which it's overlapping. It has to be by the reflexive property. And then this side in the little triangle is proportional to this side in the big triangle, okay? So all they're asking us to do is follow along and fill in the blanks. And they're telling us a proof of these being proportional is shown. Now, quick review. What if JK is 3 and JL is 9? Then JN, let's say it's 4. What's JM? That's not a 14, that was a double tick mark with a 4 next to it. This is a 4. What would JM be? Charlie. 12. Let's do it again. Ready? This side is 3. This side is 9. What's the scale factor? 3. This side is 4. This side is 3 times bigger. 12. Remember that? So, question. Does this proportion hold true for the numbers I just made up? Does that statement hold true? Well, let's check it. What's 3 over 9? 1/3. What's 4 over 12? 1/3. Are they equal? Yeah. So that's the kind of thing we're looking for. If this is true, then these triangles are similar by which of these? I don't know anything about these other sides. SAS, right? S, the angle, reflexive property. S. This is just the stuff as you read this problem you should start thinking about. Okay? Before you even look at the proof. This is the stuff you should be thinking about. All right. Wow, this is weird. Triangle JLM given. Okay, well, they're telling you it's a triangle. What else do you think they'd be saying? Which statement must? I'm with Emma. If I was reading that, I would be like, oh, maybe they're going to say the next triangle's a triangle, right? That's fair. It's all right. Now, even though everything I wrote up there, that's all true, and that's the kind of stuff we want to be thinking about. Let's see what else they're going to talk about, though. All right, J and K, and guys, don't be afraid to mark your papers. And this is where I got a little nervous as I was walking around, because I did say, please show this in your notebooks as you go through it. And this would be a problem for sure, that if you didn't write down on your piece of paper and you're just doing it on a computer, it's just asking for trouble, because trying to keep all these straight, like J and K is this angle. They tell me it's equal to JML, this angle. Okay? And then JKN is right here. And then JLM is right there. It just helps you visually to keep it straight. Just quick sketch. Mark those. All right? Corresponding angles are congruent. All right? What should bother you about that? Man, we spent a whole chapter talking about corresponding alternate interior, alternate exterior, and then this book called it consecutive interior. Or same side interior. Those are only congruent, or the one supplementary, if the lines are parallel. So how are they going to use corresponding angles there? Before that, they must have said the lines are parallel. Remember that? Corresponding angles are only congruent if the lines are parallel. So these lines must have been, we must have been told they were parallel up there. KN, it's D, KN, LM? Okay. Now, I could have explained that to you in about 5 seconds, but the part of the review is reminding you about similarity. Part of the review is reminding you about the SAS, SSS, AA similarity theorems. All right? You didn't come in on time.
Why else are they getting them right? But I still didn't.
All right, your last one, help me out when I get to it because the numbers are all messed up. Is this one?
Yeah.
Okay. Did you practice the connect line tool?
Yeah.
It says use the connect line tool. I want to show you a couple things on your computers. All right. The triangle is translated 8 units to the right. Ready? 1, 2, 3, 4, 5, 6, 7, 8. Or you could have said it was at an x value of -6. 8 units to the right is now at an x value of 2. So I'm going to put a point there just as a placeholder at 2, -4. Okay? Just to kind of hold my place. All right. So I'm going to get hey guys, please listen. I'm going to get this triangle just to visualize it. So this was at -1, -5. And so where's it going to be now? Good. 7, -5. This one was at -3, -7. So 8 units to the right. Careful. I said -3, right? Plus 8, 5. All right. Now, that's not the result because then they're going to reflect it over the x-axis. And there's some rules we had to memorize. This was one of them I didn't want you to memorize because what happens when something gets reflected over the x-axis? Do the x values change or do the y values change? Just the y's, and they become opposites, right? They become opposites. And so this point of 2, -4 is at 2, +4. This point at 5, -7 is at 5, 7. And 7, -5 is at 7, 5. Use the connect line tool to draw the result. Connect line tool. There you go. And then I don't use this too often, so I'd probably go in and practice like, okay, deleting those points out because that was the first step. I don't really want those to stay there. So practicing deleting those out. Make sense? All right. Another thing I wanted to show you, and I just found this out, to be honest, myself this morning. Click on the calculator up here. Did you guys use Desmos much last year in Algebra 1? Sometimes. Okay. Something I want to show you. Now, there's way more you can do with this in algebra than it's going to help us with in geometry. But something I figured out this morning that's helpful is how to plot points. If you say you wanted to practice that translation and a dilation maybe, you can actually plot points on here. Like I'm going to look back to get the first point, like -6, -4. Now, I would not recommend doing this. They already gave you a graph. Like we didn't really need to do this on this one. There's going to be one that we're going to be working on in class today where this may be helpful. Okay. And of course I start talking, I forget the point. -6, -4. All right. When you plug in parentheses here, type in parentheses and do -6, -4 and hit enter. Okay. You could even label that as like point J. Do you see it down there? -6, -4. All right. So now to save me some time going back there, what's the next point we had? Original one. -1, -5. And then the last one. Now you can zoom out and do all that. All right. Now you could even, I don't know if it's going to help you or not, but you could even take this and I'm curious if you're really lazy if this would work. We translated it to the right 8, didn't we? I haven't tried this, so bear with me. +8. Oh, man. You could even just type in, not even have to do the math. +8. +8. Boom. There's the new one. Now, again, I would not have done it on this problem. I just want to show you that's a capability of it. All right. You can also graph lines. You probably remember this from last year, like y = 2x. And it'll graph that line. Say you want to revolve or reflect something across a line. You could practice. You could graph in the line to remember what it's going to look like reflecting it across it. Remember reflecting across y = x? Things like that. So that is a tool. Did you see how to enlarge that screen and how to reduce the size of that screen there? And then if you want out of it, you can just click the X. Make sense? All right, was this the last one you guys were doing? All right, so we're going to work through some more in class today. I want you guys to have some independent / partner work time. The group of problems we're going to work on in class. (12 through 14, 16, and 17). So on your computers and write them on your notebook paper, please, as you go through them. Don't be lazy. Okay. Sorry, I couldn't hear you.
Are they going to be homework if you don't finish?
No, we have a
There
little.
probably be some more than that. Yeah, but yeah. Try to help you with that. All right, you want to show me your work?
No, I keep it for this.
I'm gonna have to get up there.
What?
I got you, yeah.
What are you doing?
Where?
I might need some.
That's not good.
Yeah, cumulative. I still sit on. It's holiday.
You sure? That's not good. I think I left mine in science class. You won't get some words.
Wow.
Oh, wait, no.
I got rid of her.
She also never put it in there. I don't want to stuck in there. Well, I'm gonna go.
She just says.
I don't need to tag this.
She's not gonna.
No, I don't think. How many times does she take it anymore?
It's like having it's just teach you kind of like having a pet. Get off the table.
Yeah.
Like you have a spray bottle.
No zapatos.
She like checks her homework and she never does it, so she has the Venus stuck on her face.
Never mind. Yeah. Maybe.
Why is this still showing?
How we doing, guys?
I'm good because. No, she wasn't. She did absolutely. She tries to open it. She pulled you over the side. She's like, show me what she did. While you're copying the paper on the other chair. I don't care. I still want to see around.
Oh, it's alternate.
I didn't even get it.
Okay, then why did you have it?
I can't prove that.
Yeah, pretty sure.
Let's go alternate experience. 5 and 4. Oh, that's not corresponding. It's oh.
Yeah, you see, I just forgot.
I wonder what
Oh my gosh, I could just power.
Is actually what would you guess is that kind of speaker?
Pages.
I guess that